we'll learn about commissioning in detail. And now let us take an example, my own experience of BESS with 1.5 megawatt hour solar plus BESS. I just wanted to share some of the challenges which I faced, which will be useful for you and when you are using it for commissioning or understanding in depth. So, for example, one of the challenge what I faced was with respect to the BIU, BMS, HMI software what they had for 8 rack system. And if I, this is like you can see in the right hand side, there will be a local HMI user interface will be there, which will be used to understand the BESS. But the software what they provided for us was only 3 rack. It was not for a 8 rack. So again, in the site, I have to go and commission, upgrade this BIU's BMS HMI software. And again, the commands which are there to operate the BESS with respect to racks was not enabled. So again, I have to enable those. And we have HMI, there was an installation error was coming because equipment installations was more than 100 equipment because they have inherit the HMI installation what they had. They have, well, what they installed was having less than 100 equipments and the license was that. And now when I go and install the latest software, it was not allowing because this site was having 8 racks with 13 modules. Total, it was coming as 104 instances. So it was not happening. Again, license issue was there. So again, I have to talk to the BMS vendor and ensure that the licenses are actual licenses in line with whatever we asked for. So these were all the some challenges what I faced in the software and configuration predominantly at the battery management system side. And also the firmware and all, if we say the firmware and hardware for BMS, as I discussed earlier, BMS is having a 3-layer architecture. One is battery administrator unit BAU, and then we call it the battery controller unit. It is at a rack level. Then we have a BMU, which is at a module level. And predominantly the firmware what we are going to upgrade will be at a rack level BMS and at a common BIU at a system level. So those addresses and also the configuration of those BIU, BSS, BMU at BIU level because we'll have 8 racks and the system controller BIU has to know which rack is which address. So that in the firmware of the BCU, all the addresses were given as 1. So what was happening is we have 8 racks. BAU is understanding only 1 rack because all the addresses were same. Then I have to go and hook up to the BCU with a cable and then change the address of the BCU in the firmware so that the BAU will be able to understand for a BCU, each BCU, what is the address we are given. So this and all, we did it practically at a site. Whereas if we had all the BAU, BCU, firmwares, everything configured in the factory before shipment, this and all could have been avoided in the commissioning. The other one was with respect to communication. UPS was there to power the auxiliary powers when even the controller which we are using it to control it should have a UPS power so that in case if the grid goes off, batteries are at SOC, 5% SOC, then how are you going to ensure that this is taken care? So UPS to our unit controller, we used to have a serial to RJ45 connection. So again, we came up with directly connecting to RS485 directly. So there we have reduced the cable, additional cable which was required. And emergency stop was there to operate the PCS. So we tested those emergency stop during operation. If I press each emergency stop, whether the BESS with all the racks contactors opens and the PCS will not get a DC power, so it will open AC and DC contactors of PCS. So we have checked all those things and also earthing has to be proper, so we measure those earthing also. The other one is the logic what we use and also the control wiring what we'll have between the BMS and PCS. If we don't have a proper wiring, then it leads to a lot of challenges. So I faced one of the problem what I faced is we have given drawing properly for connecting NONC contactors to the PCS from the BMS. Unfortunately, the technicians, when they were connecting it, they connected in the opposite way. What happened because of it? When I start commissioning the PCS, it is starting. PCS is starting ramping up and tripping. And when we analyze, we have to go to electrical drawing, check one by one cable, wiring, continuity. Then we found that the NONC contactors wiring was wrong. So to detect that, we took 1 day and shutting down everything, checking each and every parameters, then go and do it. So that itself, it took a lot of time. So those things can be avoided if we have a proper checklist, ensuring that each and every cables, connections, NONCs, everything is properly connected. Then the software side, we need to have a proper variables defined with the default variables, which ensure that the BMS, because we have a battery management system, PCS, we have HVAC, we have fire system. So all the initial conditions of those and variables in the logic, software logic has to be properly defined. What happened in our logic on the base BMS PCS that HVAC off enable, ideally it should be on, means I can switch on HVAC off and it should be able to operate remotely. If that parameter was set wrong, like it means that I can't operate HVAC remotely, neither I can operate. So in that case, what was happening is we were wrongly set the parameter, default parameter for HVAC. So it was not accepting any commands from our controller. So what was happening is when we started charging, we are seeing the temperature is not getting controlled, and we are seeing that cell temperature is keep increasing. And when we saw it, it was a basic issue in the software that the remote command for HVAC was disabled. So those things has to be properly checked during commissioning. The detailed checklist you have, more better it is for you to from the commissioning point of view. Then the operation findings we had. Then there was the export of power was happening. So which we have to check why it was happening, and we have to debug and then control someone. There was a wrong logic in particular conditions. It was exporting. So we resolved that logic and commissioned it. And also the fault conditions, we need to have local and remote. We should have a field signals properly so that we can ensure that any fault occurred, we need to know which fault it is. Is it because of PMU fault, or it is a PCS fault, is a PCS hardware fault, or the contactors are malfunctioning, or a fire panel is malfunctioning. So we need to have all the fault signals, and we should be able to have a local and remote. In case if they see that hooter is keep hunting from the fire panel and no one is there, and locally we are seeing someone seeing that fire panel who is hooting, but nothing is happening there. We should have a local control and see what is happening. So local remote controls are equally important for troubleshooting. The other one challenges are whatever the key lessons what I learned was hardware IOs default values, what we have NONC contactors, and wiring has to be properly ensure that they are all taken into account. Then we have a EMS and unit controller. We need to ensure that the proper handshake between the EMS controller and unit controller is happening so that we have a proper operation of BESS. What was happening is the information between ECS and unit controller is a controller at a BESS level was not, there was a difference in the variables, because of which when the ECS command to charge, we were seeing that it was not charging at a full capacity because there was a scaling factor used in the unit controller, which was wrongly interpreted. The scaling factor was wrong, because of which it was should be zero point 0.1, but they initialized it 0.01. Though ECS was commanding, like for example, 100 kilowatt, I was not getting 100 kilowatt. I was getting only 10 kilowatt. Why is it? So when we troubleshooted, we saw that the logic of EMS was correct, but EMS to unit controller, the parameters, the scaling factor in the unit controller was wrong. So those things has to be tested with a simulation and check everything is fine. Then so that we have a proper integration. Documentation also should be clear that how the overall EMS to unit controller, which operates the overall BESS, are clear what are the philosophies are there. Either we are going with the frequency regulation or it's the load peak shaving or what are the applications we have, what modes we have, each mode, how the BMS works, PCS works. We need to have all those things. Then with all those experience and delays in the commissioning, then we came up with a commissioning checklist so that that can be a reference for all down the line for any projects. So any questions